aspect of it. So, like we normally do, once again, I welcome everybody, and I will say you are welcome to another code challenging solution we normally do. So we all know our goals in this our meeting on every Sunday, and our goals tonight is to collaborate and review and solve a coding challenge to enhance and provide solving skills and improve our coding quality through the peer and feedback. So last week we tackled some challenges, though we couldn't finish, but at least we solved part of it, and as was being promised that the part of it will be completed today. So the code was presented by Taiwo.
Sorry to disturb. Is anyone seeing anything? Has Taiwo shared his screen or what?
Yeah, he said he's sharing it. I can see. I'm not sure if the screen is small, but I can see it.
Did anyone have difficulties in seeing my screen? Hello?
Hello, yeah, I can see it, Thomas. So you're sharing the PDF, right?
Yes, exactly.
Yes. Sammy, can you see the screen?
Yes, I can see the screen.
So, thank you. So, who is finding it difficult to see the screen, please? Maybe to just try to log out and log in back. Maybe you should just try to log in and log out and log in back. Maybe it might be a network issue. So can I continue?
Yes, you can tell.
All right. Our code challenge for this week is detect a circle in a linked list. Detect a circle in a linked list. As we all know, if you are talking about a linked list is just like a node. For instance, maybe they give us like a node. As you all know, a node just like a connection. That's one end and another one end. For instance, now you can have a circle with A, B, C, and D. The connection of both A, B, C, and D together give us a node. And the problem statement of this code is giving a head. The head of a linked list determine if a linked list has a circle in it. What they mean by this is that they give us a head. For instance, now maybe like this A here, this B, and C and D here. They now give us an option that, okay, giving a head, the head of a linked list, determine if the linked list has a circle in it. We have to determine if this link, this A, B, C, and D, it will be a continuous one. If it be a continuous one and it's going back, does it have a circle back? Can it make it a circle? If not, so we now proceed to another thing. So visualizing the problem like this now, linked list without a circle. Now, for instance, now we have a circle, and they ask us to check if the linked list will have a circle or it will not have. For instance, now, if you see this linked list without a circle here, image of a series connected a node like, for instance, now A, B, C, and D. As you can see, the last one here, we have a none, because you have to determine the list of the node if it has a circle back, meaning that if the continuous of our node, we have it in a series of a way that is now coming back, that is at a circle. This means that it will reach the end of the list at the node. Now, another option is that a linked list with a circle. Here we are trying to determine two things: a linked list without a circle and a linked list with a circle. So, as I already said, the one without a circle, it has a none after the end of the D. And the second one is a repetition of it, like a linked list with a circle. Imagine a series of connected nodes like this. We have A, B, C, and D. As you can see this one now, you have a B back. I don't know if you can see this part of it. We have B back. This means that this B is now going back in a two-dimensional way. That is, D is the point back of the B. This means that it can keep going around and around like that. For instance, now they give us A, B, C, and D. They now ask us that can we go back in a one step or two steps, because they give us two options. Is that you go back in one steps or two steps. If you have to go back one step, meaning that this our B, this our D here, we go back to D, we go back to C. If they give us two options, meaning two steps at a time, meaning that this our D, we go back to C, B. That's how the loop will try to continue and continue and continue and continue like that. So looking at this will give us an insight on how we can place our code, how the challenge can be tackled. Now, let's go forward and look at another analysis in this place now, using two-pointer runner to check or determine. Now, for instance, now, to determine a circle, we use two imaginary runners moving through a node. For instance, now, we have a slow runner. A slow runner we can only move in one steps, as you can see from this place. A slow runner can only move from what? Can only move. A slow runner can only move at one step, while a fast runner can move in two steps at a time. So let's now checking this one now, stepping by stepping explanation of this now. Now, initialization, first thing you have to do, giving a problem is not the challenge. The only challenge we can have is how can we tackle the problem. Once you can able to identify the problem, then automatically there should be a solution for that. Now, they give us two criteria. The first criteria is that we move in a one steps, and the second one is to move in a two steps. Meaning that you have two things to initialize. That the first thing to initialize is the slow runner that starts with the edge of the list. Meaning that if you have to create a function, you have to first define, you have to give it a parameter, which is the edge. And the edge can be in two dimensions. It's either the slow runner or the fast runner. Now, looking at the fast runner has a two steps ahead, while the slow runner will have only one step at edge. Now, looking at the moving of the runners, as you can see, moving the runners, slow runner one step forward, as you can see, one step forward, while the second one is what? Two step forward. Now, check for a circle now. If there is a circle, the fast runner will reach the end, which is a none. If there is a circle, if there is no circle, the fast runner will reach the end as a none. Meaning that if there is no circle, if you are to move, looking at this example here, from here, if the slow runner has to move, and if there is no circle, meaning that our loop has to end, because it's a non-value here, it has to end from this non-value here. From this non-value, if there is no circle. But if there is a circle, meaning that there will be a repetition, there will be a loop. So automatically, this has already given us idea of which type of code we have to use, meaning that you have to make use of while loop, because a while loop will give us an additional condition among that. If this condition is met, okay, do this. And if this condition is not met, you can do this. So looking at this now, checking for a circle. If there is no circle, the fast runner will reach the end, which is none, before the slow runner, because it moves faster. If there is a circle, the fast runner will eventually lapse the slow runner, and they will meet at some node within the circle. What they mean by this is that if there is a circle, no matter how you move, it's either you move in a two dimension or you move in a one dimension. As far as there is a continuous looping, there will be a circle automatically. Now, let's check for this example now. For example with a circle. let's consider a list A, B, C, and D. As you can see, this one now is a repetition, meaning that our first runner has moved back in a one dimension, meaning that from this D, which is the last one, it has moved back to B, which is this one. Now, initialize the position now. A slow runner at A. Now, they all start at the first position, meaning that after we declare our function, we put a parameter, which is our edge. Both the slow runner and the fast runner will take the same step at a time. They all start with our A. In this our example, in this our case study. Now, first move, the slow runner will move to B. The slow runner will only move from, it's a one step that a slow runner will move. The slow runner will move from A to B. While the fast runner will only move with two steps, which is B and C. I don't know if you are getting me. A slow runner will only move in one step, according to the constraint given to us, that a slow runner will only move in one step, which is from A, because they all start with A. A slow runner will move with one step, which is B, while the fast runner will move with two steps, which is B and C. As you can see, this one now, this is the first one, the slow runner move to B here. Now, second move, they have already moved in 1 inch. The first runner has moved to B, while the second runner has moved to C. As you can see this now. Now, if you are to move in the second dimension, that is our slow runner will move from this C. If you are getting my explanation, our second move, the move from the second step from the slow runner will be from C to D. As you can see from here, from this our second run here, our slow runner move from where we start, where we end before, which is B, move to C. This is it here. Move to C. Why our second runner, which is move in a two-step dimension, we will move. Don't forget that our first runner stopped from C. So if you have to move back, or if you have to move forward in a two dimension, we have D, B, D, A, and B, which is what it's showing here. Because it moved in a two-step ahead. Now, checking the third move now, before we summarize everything. Don't forget, in our second move, our first runner stopped at what? At C. So if you have to move another step ahead, we have to go to D. You have to go to D because it's a one step ahead. Now, for the third move, for the fast runner, don't forget where we stopped. We stopped from B for the second run. For the fast runner, which is at a two-step ahead. So if you have to go in the third move now, and don't forget that our fast runner has to move ahead. So to go from here now, we have to count another two, which is C and D. That's how we get to this place now. So now, the slow runner and the fast runner meet at D. As you can see, they all meet at D. Both the slow runner and the fast runner. Automatically, we have a circle here. That is all what they are trying to let us understand in this our challenge, that once you keep on moving with your loop, if it gets to a point whereby the slow runner and the fast runner meet themselves, automatically there will be a circle here. And don't forget, the constraint is that a slow runner can only move in a one step, and a fast runner can only move in two steps ahead. So going forward now, if the example consists of a circle, that's what we consider at the top, and a sample without circle now, if the slow runner and the fast runner does not meet at any point, meaning that there will not be a circle. That's what we are trying to treat here. Let's consider the list again. We have A, B, C, and D, and the end was known. Now, to initialize this now, the slow runner and the fast runner, they all start at the initial point, which is A. Both the fast runner and the slow runner, they all start at initial at what? At A. Now, first move now, the slow runner will move to B, from A now to B, because he only has 1 steps. The slow runner will move from A to B. That's how we get this B here. Don't forget our fast runner has 2 steps ahead, which is from A, we have B and C. This is how we get this C here. Now, if you are to move in the second dimension, the slow runner will move with only 1 step. Don't forget our last runner has a B, which is the last initial point. So if our slow runner had to move from this B to another step, it can only take 1 step, which is B is to C. That's how we get C here. Now, if our fast runner, which has 2 steps ahead, can only move in a 2 step ahead. Now, don't forget our last steps, which is C here. And we have to move ahead with 2 steps. We have D and none. Automatically, our loop will be end here, meaning that there will not be an option for us to continue again, because there will be no circle in this one. So the 2 constraints given to us that we should initialize a circle and without a circle, given a constraint of 2 steps and 1 steps. So creating a pseudocode for this is how I come about this. We have to create a function. The function has also that as a circle. If it has a circle, now this is the parameter we have to give, the head. This is the head we have to initialize. It's a function here. We define a function as a circle, then we give a parameter of head. Now, if the head is none, that if our head is empty, or our head dot next is none, we return a false. Meaning that there is no parameter. You give us 0, means there is no parameter. If there is no parameter, help us to return what? False. This is what the pseudocode is trying to explain here. Now, set the slow to edge. That is, we initialize our slow as we discuss here. Our initializer position is from here. As you can see, they all start from the same point of view, A and A. The slow runner start from A, while the fast runner start from A as well. Now, you have to set, that is, you have to initialize your slow and fast. So whatever the parameter given to here will be assigned to here, as far as it is not known from this condition. Now, using while loop to solve this problem now. Why fast is not known and fast.next is not known, then you continue with this loop. What are they trying to say in this while loop here? That is, if our fast is not known and our fast.next, you have 2 options. We have a fast, which can only move in 1 dimension, and we have fast.next, which has 2 steps ahead of our fast. So after compile this code here, we set our slow to slow.next because it has only 1 step ahead. Now the second option is that we set our fast to what? Fast.next, which can only give us 2 steps ahead, as discussed above before. So if slow equal to fast, then return true. So automatically this will give us a loop, a circle. As far as our slow is equal to fast, we get a return from the circle. So if not, then it will return false. So initialize this with our LeetCode problem now. So let's demonstrate it on our on our code challenge platform. So let me know if you can hear me and understand this particular area before we go to the website of the challenge. All right, thank you.
I'm following. Yeah.
Yeah, thank you.
Unfortunately, from my side, I'm seeing only blank screen.
Oh,
yeah, you can check
see
your
only
WhatsApp to
blank
see what's
screen.
happening.
Oh.
I'm gonna restart it. I'm just requesting. I'm requesting for a bit of time, maybe 5 minutes.
Okay, no problem.
So let me know if you can see my screen right now.
Yes, I can see me on my side. I can see.
All right. So explain this particular area now. We have to. Okay. Wait. This is the last. This is the last one we did.
Welcome, Taiwo.
Yeah. So, like I was saying, this is the code provided for the solution. Now, how do I get about this? Like I told you earlier, we have to define a function. The function will tell us that whether we have a circle or we don't have a circle. So we define this circle as a circle, which give us a parameter with edge. And this edge now, you have to pass some parameter into it. That if it's slow, if our edge is slow, we give whatever the answer it is here. Whatever the parameter we pass here, it will be here. Now, if it's fast, it will edge.next, like I was explained before. Now, getting our while loop. Why slow is not fast? If it's not fast, mean that they are not equal, because we are trying to treat a circle as a circle here. And if it's not fast, if not fast or not fast.next, we return a false. This is what I try to explain in our pseudo code earlier, because this give us or check for us if the list is empty. If it's empty or it's not empty, then it will return false. But if it's true, then we continue. So this our slow now will now become slow.next. Don't forget that we only move in one step for slow, and our fast is equal to fast.next.next. This gives us a 2-step ahead. For instance, if we give us one here, mean that this one will be 1, 2, 3, because it can only be going in a 2-dimension for it. It can only be going in 2 dimensions for it. So, and this will return a true as far as this code is concerned. So once slow equal to slow.next, this take 1 step ahead. Slow.next.next, this take a 2-step ahead, and this will return a true value. Now, getting our helper function to create a circle in a linked list for testing. Now, we create a function again, and this function will create a list. This function will create a list for us. This function will create a list for us. So if not a value, that is, we have to pass a parameter here. And this first will determine the number of steps we pass in. So if not a value, then we return none. And if our head will become list.node, then our value, which is our index of that value. So our current, it will become head, while the circle node is come none. So now we have to look through it. For our I in the range of the length, the current.next will become list node at a value of I, meaning that it will keep repeating itself until we get to the current we need. And the current will now become current.next. And if I is equal to pause, then circle node will be equal to what? The current. Now, if our pause is not equal to -1, the current.next will become what? Circle.node. And this will return a what? A head. And checking this now. Now let's try to run the code now. I think I have to log in or sign in here before I can run the code. I'm so sorry, I should have logged in before starting the program. So I have tried to log in now. So let's try to run our code and see the outcome. So we have an indentation error here, which is line 2.
Line 2 on top, I think the class linked list. Indentation of the while, line 17. The class solution, do you have the class solution? Where's the class solution? It's figured out.
What do you say?
The class solution. I think you need the class solution.
I can't hear you very well.
Hello. Go up. I think on line number 9. Line number 9 or 8. Number 7. You're not supposed to have a class solution there, so that you can call their input.
Okay. Come
Class solution object.
the object of the solution, right?
Yeah. I think the one that they built themselves. Just before the method has cycling.
I think they have their own parameter, which is a solution, which is not defined yet.
I put it on box. I think they have it on their link list.
What do you say?
I put it on the chat box. Check and then put it on number 7. I think should be there. That you can call it.
On where?
Check chat box. Chat.
Checkbox.
Yes. On chat on our team box. Chat on a team box.
On the group, right?
Okay, let me put it on the group on WhatsApp and then.
Okay, thanks.
Between lines 6 and 7, are you not supposed to jump one line? Where you defined line number 8, just is it not supposed to be in line number 7?
What number?
Okay, it should be class instead of the.
The class. I think they should call the class solution because they have the class on their on themselves. That the one that checking if our solution is correct. I think it should put number between the number 7 or number 6 here.
Let's kill this laptop. I know.
Okay, check our name has slightly. Is it the same on the one that defined there? Name is the same. Is it the same? Name is slightly 7 head. So why it says it's not defined? Oh, it got 2 parameters. Got a self and head. I think calling 2 parameters, isn't it?
Liu Kang wants to take our place. It's time for my brother to step up. I don't want to be a gangster, but I just want to do what I want. We have a win for that Taiwo.
Why you say the name is wrong? Because I think it's the same cycle.
Exactly.
Okay, let's check line 50. We have line 50 here.
Line
50, line 50. 50. Okay, yeah. Okay, here we got two parameters. Print has cycle.
no.
Okay, you're calling that method to verify our list, our output.
What is it?
I'm saying on line 50, are you calling our method, the one on top there?
Exactly.
Okay, I think it's not defined from outside its class. Okay, try to run it, comment it out.
Yes. Yeah, I think it worked like this.
Okay, let's run it.
So I don't know what actually happened, and it's not running on the printing command.
But look like did it accept our
Yes,
code?
yeah, I think it's still accepted.
I think it's still accepted.
Yes. So and it's already defined here. So I don't know why it's the calling of the function is not printing here. Maybe I will check it later. Maybe the second guy can let me give room for the second guy to continue his own presentation. As far as this one
submit and see. I want to see the time efficiency.
All right.
But line 16. Why is it going? And 16 says there's no attribute.
Exactly.
Can't you reset your runtime again so that it can refresh, and because the other side is accepted and on the other side it shows the runtime error? So can't you reset your runtime error?
So how will I do that?
Okay, from the HackerRank website, there's an option. So here I can't see because I logged in using my phone.
Okay.
There's a button there, then it gives you an option somewhere around
To
on your
reset
right
the
hand side.
to reset the runtime. Can Sammy get that? I'm just trying to look for the reset option.
Okay, go up. Maybe let me check. On a linked list class, did you assign setnet to 9?
What do you say?
On the linked list, on the class link node, or but it's assigned the safe dot net assigned to 9.
I can't really get you clearly, please.
Let me check, but I think okay. Huh? Go up. Go up again. From here.
From where?
And uncomment the class link list. On top there, from line 2 to 3 to 5. Check out the comment. Check out the hedge. Uncomment it.
Okay.
Until class. Okay, move a little bit class to no that one, comment that one. I think it's that one is just a comment. Comment definition. Put hash on a definition. Which I think destination is gonna affect us also. Okay, from here, because until number go down. Go down again. Until number 24. I think that code should run fine. If you can come, okay, you need to indent them. Python sometimes that's a problem. And then you can comment it from number 26 until the end and see if this can run.
Okay.
Comment number 26 until the end there.
No.
Try to run again.
Yeah, hello. Can
Hello?
anyone hear? Yeah, I think I've run this one. It's working fine.
Looking fine. Okay.
So let's submit and see. I think it's still the same error. Line 15.
Still giving the same error.
Yes.
If you take out the code from cut the code from 26 until the end, until 50.
Okay.
Still giving a runtime error.
Yeah, you see the attribute nest. Object does not have an attribute of nest.
Try to refresh the whole URL.
The entire website, right?
But don't press that one. Yeah, maybe on a link. You see on a link there. Press on a link to refresh on top.
This particular one.
No. On a URL, not on that
Okay,
one.
this please.
Yeah.
Okay.
Why is it? Why that thing is not moving? It's not coming out.
What?
Okay, press. You see where it says all submission. Press the error that's showing you back.
Is it showing the same error?
You see where there's an error message.
Yes. The attribute
There's says all sub. There's a all submission, and then there's an error that's showing back, going back.
But as you can see now, there's no line 62 again in the code now.
It removed the code.
You have to remove the code, but it's still showing here at the line 15, 50, and 62. Whereas the code was end as 26.
You see on where there's an error message.
Yes.
There's where it says all submission on top there. All submission.
All what?
All submission. There's a button that says all submission.
So this one, right?
No, down. Second down. Go down.
Okay, all submission.
Go down. Yes, this that one. Go back. Yes. Press that. Go back. Error. Why these errors are running?
Runtime error.
Okay, save the code. Copy that code and then run reset. It's gonna take it. Copy it out, and then so that when it get lost, you can paste it back.
Okay.
And then run it default to reset. Okay. And then paste it back, but that thing is still not going.
This one, right?
Yeah, paste it back again.
still have the same issue. I
Why?
guess maybe
Maybe you need to sign out and log in again.
okay, no problem. Maybe let's the other guy should be continue with the other presentation.
Okay.
I will try to check it for
Okay.
the
Okay. No.
error message. All
But
right, thank you.
thank you very much for your time and a good presentation.
All right, yeah, well, thank you.
Yes. Kunzi, are you ready?
I'm not ready. Unfortunately, I've been unable to log in back.
The machine. Okay.
I
Okay.
sent
Should I?
in my on WhatsApp group, so I don't know what to do. Maybe, well, I don't know what to do anymore.
Okay. Should I do that last week when that the one was not presenting? That the
Yes,
show.
yes, please.
Okay.
Thanks.
Yeah, you can continue with that.
Okay, and then maybe I can just finish Kunzi's WhatsApp. Because you can see my screen. Hello.
Yes, go ahead. We can see you.
Okay.
Yes, go ahead.
You can see the one that Taiwo was running. It ran on my side, so I'm not sure what was wrong with his. Okay, let me try. Last week we were doing. Hi, everyone. Last week we were supposed to we were doing this challenge, which got some computer error. Okay, our challenge was that maximize odd binary number. You are given a binary string which is S that contain a binary list, at least one, which is 1, and then we have to rearrange the bits in such a way that the resulting binary number is a maximum odd binary number that can be created from this combination. Return a string representing the maximum odd binary number that can be created from the given combination. Note that the resulting string can have a leading 0. Here we are giving an example where S is a list which is a 0, 1, 0. So we must rearrange this to have a leading 1, which gives us an odd number and a maximum odd number. And then sometimes we have 0, 1, 0, 0, 1. We must return it as an output of 1 and then 0, 0, 0. So solution was the problem is to find the maximum number, binary number that can be obtained by rearranging the bits of a given binary string. So our solution is to go from counting numbers of ones. Remember, our binary code is 1, 0 is one way the computer reads. So we must count the number of 1 and 0 in the input binary string, contracts the maximum odd binary number, and then to make the number odd, the least significant bits, the rightmost on your right must have a 1. So to differentiate between an even and an odd binary, the odd must have a 1 at the end, and then even must have a 0. Arranging the remaining ones and totally in count of -1 in the most significant position to make the numbers as large as possible. Fill the rest of the zeros with 0. Fill the rest of the position with 0. Or the strategy should ensure that we get a possible odd binary number. So our solution was that they have already a class solution defining the method of the maximum odd binary number, counting the number of ones and zeros inside the method. You count the number of 1 and 0 in the input string, and then we contract the maximum odd number. If there are no ones, return an empty, which is impossible to form an odd number, an odd binary number. And then otherwise count the ones. We created a variable called count, and then you minus 1 in those numbers at the beginning, followed by the counting the number of zeros, and the one that we minus here must put it at the end. This was running the induction. Plus, then should I? Okay, let me go to the code. This was our code. Okay, first let me try and define what we have. Binary numbers. This is binary 1, 0, 1, and then we have 1, 0, 0. In order to verify this is an odd, and then this is an even number. Then how do we see? What do you see? Is it true? This is an odd. Okay, we convert binary numbers to decimal numbers. The normal numbers 1, 2, 3, 4, 5. So we say okay, 1 2 to the power of 0 times 1 plus 2 to the power of 1 times 0. This 0, and then this 1 we count it, and then plus 1 times 2 to the power of 2. So from 0, 1, 2, and then we do arithmetic. Say 2 to the power of 0. This is 1. 1 times 1 is 1, and then plus 2 to the power of 1 is 2 times 0. That gives us 0. Plus 2 to the power of 2. That's 4 times 1. That gives us 4. It means 1 plus 0 plus 1 is 5. And this is an even number. I mean an odd number. And then to verify this, 1, 0, 0 is an even number. So we say 2 to the power of 0 times 0, this first 0, plus 2 to the power of 1 times 0 again, the second 0, plus 2 to the power of 2 times 1, this one. So we say 2 to the power of 0 is 1 times 0, that gives us 0, plus 2 to the power of 1, that's 2 times 0, that gives us 0, plus 2 to the power of 2, that's 4 times 1, that's 4. So 4 plus 0 plus 0, indeed that's even number, give us 4. We can we did verify that a number that ends with 1 is even, a number that ends with 0 is, I mean, the number that ends with 1 is odd, and then the number that ends with 0, it is even. So we go to our code. We have defined the method which is maximum odd binary number, and then we create a variable called count of zeros, and then we just strings the one that contain these zeros, 1 is binary, and then we count the number of 1 in that string, how many 1 we have, using the pitching method count. And then we go to line counting the number of 0, we're counting the length of how many strings we have in this string S, and then we minus zeros. That will give us how many zeros we have here. And then we go to the if.
Sorry, I can't. Sorry to interrupt you. I can't see the presentation page.
Yeah, you can see.
the presentation page.
It's not sharing. Okay, let me try stop.
Better.
Can you see now?
Yes, please.
Where am I? I'm on the LeetCode.
Yes, the LeetCode.
Yes, okay. Okay, let me start afresh. Can we start from here? Okay, this the PDF was already the method diff maximum odd binary number with the parameter self and s, which is our string, that's the input string. And then we declared a variable which is count underscore ones. And then remember our strings, the input string, which is zeros, 1 and 0. And then the built-in count is counting the numbers, counting the ones in the string, how many ones we have. And then go to line number 8, we're counting the zeros, how many zeros we have. We say, okay, how do we solve this one? We count the length of the string. Okay, let's say string is 3, the length of string is 3, 1, 2, 3. And then from there, we minus the ones, the one in the string. So let's say each year we have 0, 1, 0. And then we say you count how many strings we have here, we have 3. And in that string, we minus the ones. So if we minus the one is only 1. And then it means we left it 2 zeros. So we know zeros, we have 2 zeros. We already counted the ones on the first line. And then we say if the count of ones is, if there's no 0, if there's no 1, if the count of 1 is equal to 0, we return empty because we can't have a odd number if there's no 1. And then we come to now to define the odd number. We say the maximum odd number. We say max odd number binary, and then assign ones. We multiply with ones. We multiply ones by ones, and then we only minus only 1, the one that we're gonna carry. And then we say zeros. We multiply zeros. You check how many zeros we get, how many ones we got there. We got 1, and then we multiply those 1 by 1, and then we minus it. That's 1 because here we have only 1. And then we concatenate. Here is not a additional one. This plus sign is a it's not an addition of numeric number, but you combine it's a combining plus number on Python here. And then we count it with a 0. We multiply zeros. Okay, we see how many zeros equal to multiply 0 of zeros with the number of 0 we have, which is there are 2. There are 2 zeros, and then the one that we minus here. We combine it, we coordinate at the end. So we never lose actually when you just carry it 1 here. So if let's say if there was 0, 1, 0, and then we're counting this how many zeros we have 2 zeros. How many 1 we have 1 ones. So when we run that code, code number 13, we multiply the ones, and then we minus 1. So we say, okay, 1 multiplied by 1 is 1, and then we minus 1. So we are left, there's no longer, it is empty now, there's no 1. And then we multiply 1 by the number of 1, multiply zeros by the number of zeros. Say, okay, there are 2, we give 0, 0, and then the 1 that we carried, it come here at the end. So now we have an odd number which is 0, 0, 1. A maximum number between these two numbers. Between 0, 0 and 1. To check if this number is maximum, we say we can convert this one to decimal numbers and see if this number is bigger than this one. So we managed to convert one to the odd number, which is 0 to the power of 0, 0 times 1 plus 2 to the power of 1 times 0, 2 to the power of 2 times 0, which is 0 plus 0 plus 1, which gives us 1. So we have an odd number, which is 1. Yeah. And then if this number is odd, and then we return odd. And then this should run. But I checked it before, so it ran, and it does. And you can see here 0, 0, 1, 10 to 0. And then on case 2 here, it check how many zeros we have with 2 zeros and 2 1s. And then to get a big number between these two, we first leave 1 at the beginning, and then the zeros between, and then 1 at the end, so that you can have an odd number. This one is for the odd. This one is can get the biggest possible number we can have. And then this was expected. It beats 93%. Beats 93 people analyzing 93% or 94, because it ran on a linear peak of a linear space time and also linear time complexity. So it was kind of a faster algorithm. I think that was it, unless if you have any question. Hello. Hello. Oh, unless you can just do fast the Hooters one, because I think it was the easy one. You just
No.
you can just code this one of. But I think I did it. The Hunter one. Hello.
From my side, are you done? Yes, it's easy, but unfortunately.
Okay, we can just do it now. I can do it, and then because I already did it, you can just run it through to check. And then next week, maybe we can just recheck it. You can see my screen.
Yours or mine?
Mine. You can see my screen. My screen.
What? Yes, sure.
You can see. Okay, we were given an integer n. Perform the following condition action if an n is odd. Remember, we just talked about the numbers odd. Print it with if the n is even, and then is also inclusive range of 2 to 5. Print not with. If the n is even and also inclusive range of 6 to 20. Print with. And then if the n is even and greater than 20, print not with. So I ran the definition of is created the method is n is with, if n divided by 2, if n divided by 2, and then we're looking for a remainder. If a remainder is 1, we print with. This is confirmed, this one, if it's 3. And then, or else, if n is divided by 2, a remainder is 0, and also n is greater or is equal to 2, and also n is less than or equal to 5, print not with. Or else, if n divided by 2, remainder is 0, which is even, and n is greater than 6 or is equal to greater or equal to 6, and n is less than or equal to 20, print with. Or else n divided by 2, remainder is 0, and n is greater than 20, print not with. And then I call it the function at the end there. And then it's ran. It went through. I just wanted to make it fast. Hello? Hello? Is everyone here?
Yeah, with you.
Hi, I'm still here.
Okay. Did you see where the president that's short one?
Pardon?
Did you saw the solution?
Yes, I saw the solution. That's what I got earlier on when I was doing it. And thanks for doing it again.
No props. Okay, and then we can just, I think we are done. Thank you very much, guys, for attending. Hopefully your machine will fix next time.
I don't know,
Okay.
guys. Maybe contributions
maybe
for
can
a new
present.
laptop. Guys, don't be
We
quiet.
can present.
Sami, Taiwo, can you please unmute yourselves? I'm serious.
Hello, what
I'm
is it?
sorry,
What is
guys.
it?
Like, I'm serious.